Okay, let's start with the simple problem. The example 1 we are going to discuss. Example 1. What is the diameter of a solid circular shaft which can be used to transmit a torque of 40 kN if the shear stress is not to exceed 80 megapascal? Okay. The constraint limit is given, the 80 megapascal. We have to design what is the diameter. The diameter we have to design, the torque should be transmitted is 40 kN. Then the modulus of rigidity also given. Also, what is the angle of twist in a 1 meter length of the shaft? Okay, it's a very simple problem. Let's start with the simple one. Okay, then I will write the torsion formula in here. What is the torsion formula? T over J is equal G theta divided by L is equal tau over R. Tau over R. Then in here, what is the torque? Torque apply. This is torque of 40 kilo Newton meter. Then J D tau max. So actually, where's the tau is maximized? So earlier I explained in theories, tau is shear stress is maximized at the edge, no? It shear stress having this kind of variation, no? This is the maximum shear stress. That means the maximum R value at the edge it is maximized. R is maximized, tau is maximized. So then tau maximum value not to exceed 80 megapascal. Also, what is the angle of twist in here? So then in this equation we are designing diameter for a critical situation. The safety factor and everything not given, detail is not given. So we are designing this shaft diameter for a critical situation. So then I will write this equation. I am going to use this equation, these two. T over J is equal tau over R. Tau over R. Then J we have to find the J. What is J? If diameter is D, 5 D4 over 32. That value is not given. We are going to find the D. The T 40 J 5 D4 over 32 is equal tau. Here the kilonewton meter. We have to multiply by 3. Okay. Then the tau shear stress is given 80 into 10 to the power of megapascal 6. R, what is R? D by 2. D by 2 is the equation. So then we can simplify this equation. 1. Okay, I will cut this one in 3 and 2. Here also 16. Then then 1 divided by 5 D into 3 is equal 2 into 10 to the power of 3 D by 2 into 16. Okay. So then if we make D into subject, it is equal 16 divided by 5 into 2 into 3. Then we are getting the D value. Let me find the answer for this one. 16 divided by 5 into 1000 into 0.136 0.1365. That means in meters we are getting. So that means the diameter D is equal 136.55 millimeters. This is the required diameter in a critical failure situation. Minimum diameter required. Okay. Then this problem again asking the angle of twist in 1 meter length of the shaft. The shaft material has the modulus of rigidity G. So then in this situation we can use this equation. The T over J is equal G theta divided by L. You can use this equation also. I am using this one. So what is the torque apply? 40 into 10 to the power of 3. Then now we know T value. Then we can directly find the J also. J is equal 5d4 over 32. 1365 into 4 divided by 32. J is equal, is the J value, shift 5 into 3.408 into 10 to the power of minus 5 m into 4. Then 3.408 10 to the power of minus 5 is equal, the modulus of rigidity also given, the 80 gigapascal, 10 to the power of 9, theta divided by 1 meter length. So if we make theta into subject and simplifying, you will get 0.0145 radians. You will get this answer. Okay, a very simple equation. We have to direct substitute on this equation to find the unknown. So let's move to some advanced example. Example 2. Okay, this is the second example we are going to discuss. You can see the shaft BC, the B and C, B to C is a hollow shaft with the inner and outer diameters of 90 mm and 120 mm respectively. Shaft AB and CD are solid shaft of diameter D is a D. For the loading shown in the figure, determine the maximum and minimum shearing stress in the shaft BC. The required diameter D of shaft AB and CD, the allowable shearing stress in the three shaft is limited to 65 megapascal. So the one data have to give the modulus of rigidity. Yeah, the required diameter is not it. Yeah. Then let's see how to solve this problem. The solution, first I'm going to write the torsion formula. T over J G theta divided by L is equal tau over R. We are going to use this equation to find this unknown to solve this problem. So I will draw the free body diagram for this first initial step, the free body diagram for the given shaft. Free body diagram for the given shaft. The AN, then the B, the BN, the CN and DN. At the AN, what is the torque apply? 6. This end also 40 kilonewton. at the Cn torque apply 26 kilonewton meter. At this end, yeah, 26 again in this direction, 6 kilonewton meter torque. This is the free body diagram. We have to indicate the dimensions also: 0.9, 0.7, 0.5. This is the complete free body diagram for this application. Now we can proceed. Okay. Then when you are going to find the shearing stress developed in this BC shaft, first thing we have to know what is the internal torque it is subjected. Then how to find this one? What is the method to find this one? I am going to section somewhere in this kind of position. So then I am going to consider the equilibrium of this right hand side part. Okay, I am going to section at this end. What is the torque at here? It is 6. Here it is 26. Okay, what should be the torque in here, and what is the direction of it? It means what is the torque apply on, what should the torque apply on this cross section to balance this, because it is in equilibrium condition, it is not accelerating. To balance this force torque, there should be a 20 torque in here. This is the way we are finding the in this kind of applications. This is the way we are finding internal torque development. The section, then consider the free body diagram of the separated part. Okay, that means the shaft BC torque developed in the BC shaft is equal 20 kilo Newton meter. At the same time, what is the torque developed in the AB? TAB, if we draw the free body diagram for this left hand side part, here it is 6. In this direction there should be a 6. So what is shaft TCD? If we section somewhere in this kind of position, 6. In other direction there should be a 6 kilonewton meter torque is subjected. These are the torque applied on this AB and CD and BC shaft. Okay, then let's move to the maximum and minimum shearing stress in the shaft BC. The maximum shearing stress refers to the maximum radius at the edge. Because it is a hollow shaft, the shearing stress maximize at the edge, the minimize tau minimum at the internal surface. Okay, then we are going to use this equation that T over J is equal tau over R. To find the maximum, we have to substitute the R maximum radius, outer radius. Then first we can find the J. J is equal 5 d4 minus d4 over 32. J is equal 5. What is outer diameter is given as the data. Outer diameter is 120. 0.12 into 4 minus 0.09 into 4 divided by 32. J. Okay, J. Then I will find the answer for the J. One 1.391 into 10 to the power of minus 5 m into 4. The unit is m into 4 because r is quad e, you know. Yeah. Then maximum you are going to find what is the torque applied. Torque it is subjected, we have found already 20 into 10 to the power of 3 j 1.392 into 10 to the power of minus 5 is equal tau maximum. If you find the going to find the maximum value, we are sub the maximum r value 0.06. so by simplifying this equation we will get the tau maximum. Okay, tau maximum. Okay, then if you want to find the tau minimum, how to find tau minimum? Again using this equation, 20 into 10 to the power of 3 j 1.392 into 10 to the power of minus 5 is equal tau minimum. You have to substitute the minimum radius 0.045. then by making the tau minimum into subject, we will find the answer for the minimum shear stress developed. Okay, this is the way we are answering the first part of the example 2. Okay, then secondly, the required diameter D of shaft AB and CD if the allowable shearing stress is in the shaft is limited to 65. I will do for the AB, then you can find the diameter for CD as a homework. Okay, 3 4 5. Here it is 4, here it is 5, no? It is 5, here it is 6. Okay. Then the required diameter D. Yeah, let's consider the diameter for the diameter for the AB shaft. Then again I am using the T over J is equal tau over R. The maximum shear stress refers to the maximum diameter. The T, what is the AB shaft is subjected 6, no? 6 into 10 to the power of 3. Then the J we have to find the 5 D4 over 32 is equal, what is tau? Tau maximum 65 into 10 to the power of 6 is given. R D over 2. In this equation just simplify the 6 divided by 5 D3 into 16 is equal 65 into 10 to the power of 3. Into 16, 5 D into 3 is equal 65 into 10 to the power of 3. By making D into subject, 6 into 16 divided by 5, 65 into 10 to the power of 3 into 3. Then this is the answer for the shaft, the diameter for the shaft AB. Then as a homework, do this one also, the next diameter required for the CD shaft also. Okay, let's move to the power transmission example, the example 3. Okay, example 3, the power transmission application. A solid steel shaft ABC of the diameter 50 millimeter is driven at A by a motor that transmit 50 kilowatt. Transmit 50 kilowatt to through the shaft at 10 revolutions per second. That means motor produce the 10 revolutions per second. Okay, this is the motor torque. It is rotating in this direction. Then the gears at B, you can see the gear wheels at B and C taken out this transmit power. The B taken out 35 kilowatt. Here this taken out 35 kilowatt. Then C is taken out 15 kilowatt. When taking this power out from the shaft, opposite torque develop on the shaft. If this is the torque developed by the motor, this opposite torque we can represent in this way: TB and TC. Okay. At these ends, the opposite torques are developed. Okay. Then respect to the compute the maximum shear stress tau max in the shaft and the angle of twist. Okay. The same as we are using this torsion formula, T over J G theta divided by L is equal tau over R. Then we are using P is equal 2,5 in T equation also. Yeah. Then here, what is the torque developed by the motor? Okay, what is the torque developed, input torque from the shaft to the shaft from the motor? This equation, we are going to use this equation. The power transmitted to the shaft is equal 50 into 10 to the power of 3. The 25, what is the number of revolutions per second? 10 into T. Then we can calculate what is the torque developed by the motor at this speed, 10 revolutions per second speed, because it produced the power 50 kilowatt. I will find the answer for this one. The torque for this one is equal 796 Newton meter. 796 Newton meter. Okay. Then again at the same time I am going to find the TB and TC also. The 35, it is taken out the 35 into 10 to the power of 3, 25 in 10 revolutions per second into TB. The TB answer is equal 557. Same way we can find the torque apply on the TC also. 15 into 10 to the power of 3, 25 into 10 into TC. TC is equal 239 Newton meter. So that means addition of these two should equal to this one. Yeah. The 9. Yeah. Then we can draw the free body diagram for the shaft in this way. This is the applied torque. This motor end 796. Then the opposite torque, because the power taken out, the 556 57. Then again there's another opposite torque, 239. This is let's take this AN, the BN and the CN. So then I'm going to find the TAB. What is the torque developed in the AB shaft? So what is the method we are using? We are going to section. Then I'm going to consider the left hand side part. What is the torque applied in this end? 796. What should be the torque in here on this cross section to balance this one? 796, because it is this part should be balanced. The torque apply on this shaft should be balanced because it is not accelerating. Then 796. Then that shaft BC, where the torque developed in the BC shaft, I am going to section somewhere in here. Then I am going to consider the right hand side part, 239. What should be the torque in here to balance this one? 239 kilo Newton meter, kilo Newton meter. Then now we can easily find the shearing stress developed in this shaft. So problem asking to compute the maximum shearing stress. Compute the maximum shearing stress because this diameter is same. Because the diameter is same for the AB and BC, the maximum torque is refers to the maximum stress is refers to the maximum torque. So that means the maximum shear stress developed in shaft AB. Then that can be found using this equation. T over J is equal tau over R. Tau is equal T J into R. Tau is equal T. What is the torque developed? 796 into 10 to the power of 3 into R. Maximum R value. R means the radius. The diameter is given the 50 millimeter in diameter, 50 millimeter in radius. We have to substitute 0.025 divided by J. 5 D4 over 32. 0.05 into divided by 32. Then find the answer for the tau. The 32.4 megapascal. Please check this answer. Okay, see the maximum shearing stress developed on the, that means that is developed on this shaft, AB shaft at the surface, Then the 9. Then the problem is asking to find the example 2. The angle of twist in shaft AC. The 5 AC is equal 5 AB plus 5 BC. 5 AC is equal, what is the 5 AB? Using the torsion formula, if we the T over J is equal G theta divided by L, by making the theta into subject, T L G J. Then T A B, I will write this in this way. 5 AC is equal T A B, then L A B divided by G. The G is common for the both the shaft. Then the J also common for the both the shaft. T B C L B C G common J. Then the 5 AC is equal the TAB. What is the TAB? What is the TAB? 796 into 10 to the power of 3. What is LAB? What is the length of the AB shaft? 1 meter. G given 80 gigapascal 10 to the power of 9. J, the 5D4 0.05 into 4 over 32 plus TBC 239 into 10 to the power of 3. What is the length? 1.2 meter is given. G, again the 80 into 10 to the power of 9. The J, 0.05 into 4 divided by 32. Then simplify this equation, you will get the angular deformation, angle of twist, radians. Please check this answer, 0.02 radians. Okay, then I will give this note also as the attachment in the comment section. See the comment section, description. See the description to find these papers also.